In this video, we are going to study about permutations of R element selected from n element, and we are going to use this formula for that one. Permutation n with R is going to be equal to n factorial over n minus R factorial is going to be. And why we are using permutation? We are using the permutation for arranging the things. From n element, if we are selecting only R of them, we are going to use this formula. Let's say in the example, there are 4 letters, the letters of Kano. By using these letters, you are going to use 2 letter combinations, 2 letter words we are going to find. In how many different ways we can do this one? At the beginning, we have 4 letters and we are going to make 2 letter combinations. So we are going to find permutation 4 with 2. Permutation 4 with 2, I'm telling because from 4 elements we are going to take 2 of them and we are going to arrange them. So it's going to be equal to 4 factorial over 4 minus 2 factorial, which is equal to 4 times 3 times 2 factorial over 2 factorial is going to be 2 factorial and 2 factorial. If we simplify, the answer is going to be 12. So 12 different 2-letter combinations are possible going to be. If we check the table here, we are going to understand that here also, when you check the table, all the possible combinations there are here, and as you see, there are totally 12 different ways we can combine. The permutation questions, the important part is cannot be used more than once. So something can be used more than once, you cannot use permutation. We should know that one also. Okay, here 1, 3, 5, 6, and 7. These are the these are the digits, and we are going to make 3-digit numbers by using these numbers. And in this set, we have normally 1, 3, 5, 6, and 7, and I'm going to make 3-digit number. So from 5, I'm going to select 3 of them, and I'm going to find the how many different permutations there are. 5 factorial over 5 minus 3 factorial is going to be equal to 5 times 4 times 3 times 2 factorial over 2 factorial is going to be, and when you simplify this 2, 4 times 3 is equal to 12 times 5 is going to be equal to 60. So 60 different 3-digit number we can write, and each number we are going to use only once. This is the important part. Okay, let's see another question. This question also similar with the previous one because we have totally 30 raffle tickets and we are going to select 3 of them, and this is going to be permutation 30 factorial over 30 factorial over 30 minus 3 factorial is going to be, I'm not going to continue to this question because similar question we solved before. Okay, this question also it is same. A fighter plane has seats for the pilot and co-pilot. We should understand also here pilot and co-pilot, they have different jobs, so we are giving different jobs to people. If we have given same jobs to people, we cannot solve like this. So what we are going to do here, we are going to use permutation again. So if there are totally 18 pilots and 2 of them, if we are selecting, this is going to be equal to 18 factorial over 18 minus 2 factorial, which is equal to 18 factorial over 16 factorial is going to be. I'm not going to solve the question because it is similar with the previous one to see different. Okay, how many different combinations? At least 3 letters. Yes, this is at least 3 letter question. At least 3 letters means 3 or more. So this is different than, a bit different than the previous types. So we are going to do like this: 3 lettered combinations plus 4 lettered and plus 5 lettered combinations we are going to find. So totally we have in the maths word we have 5 letters. So from 5 we are going to select 3 of them and we are going to arrange them. Permutation 5 with 3. Then we are going to, from 5 again we are going to select 4 of them, and from 5 we are going to select we are going to select all of them. So permutation 5 with 5 is going to be. This is equal to 5 factorial over 3 factorial, pardon, 5 minus 3 factorial is going to be 5 minus 3 factorial. This is 5 factorial over 5 minus 4 factorial plus this is 5 factorial directly. It's going to be, because we know that permutation n with n is equal to n factorial. So here it's going to be 5 times 4 times 3 times 2 factorial. In the previous question we found this one, and it's going to be equal to 60. This is 5 times 4 times 3 times 2 times 1 factorial. 1, there is no need to write, but down is 1 factorial, which is equal to 1 also. 1 factorial is going to be, and this is going to be 5 times 4 times 3 times 2 times 1. And this part is going to be 60, and this part is 5 times 4, this one and this one, it's going to be equal to 1. 5 times 4, 20, times 3, 60, times 2, 120, and 5 times 4, the same result, it's going to be 120, 120, 120, 240, and plus 60, that's going to make 300. Here, only important part, we have to be careful about this addition signs. We have to be careful about this addition signs, because at least 3, when you say, it means that 3 letter, 4 letter, and 5 letter. And 3 letter, when you are selecting with 3 letter, you cannot select 4 letters, or you cannot select 5 letters, because totally you have 5. That's why these actions cannot happen together. When it cannot happen together, instead of multiplying, we are using addition. And this is a kind of addition principle question. Okay. Camel book's case has 3 shelves. So in this question, we have 3 shelves, and we can arrange the things together. At the same time, we can arrange the things. In this question, you cannot arrange them at the same time. That's why we add. But in this question, we can add the things together. That's why we can add the things together at the same time. I mean, if we can add the things at the same time, it means that we are going to multiply them. Kemal has 5 different math books, 6 different biology books, and 7 different physics books. And he wants to arrange 3, 4, and 5 physics books on a shelf, each shelf for one subject only. In how many different ways can Kemal arrange his books? We are going to do like this. 5 different math books he has, so we are going to do permutation 5 with 3, because from 5 we are going to select 3 of them, and times is going to be not plus, because we are doing this one at the same time. Permutation 6 with 4 times permutation 7 with 5, it's going to be. And we are going to add here 3 factorial. Why 3 factorial? Because there are 3 type of books. Group arrangement. This is the group arrangement it's going to be. Okay, and this is the answer of the question is going to be. Okay, this question also it's important. Why this question is important? Because it is different than the other questions, and we are finding not contain here. In the previous questions, always we were finding the positive meaning. Here it says it gives the negative meaning. And for the A, we are going to do like this. If it says do not contain the digit 5, so we are going to select this from the set 1, 3, 4, and 7, 8, and 9 we are going to use. So how many different ways we can arrange the numbers from this set? We can arrange 6 factorial different way. We can, we are going to write 3-digit number. So from permutation 6 with 3 it's going to be, because we are writing 3-digit numbers. Okay, permutation 6 with 3 is equal to 6 factorial over 6 minus 3 factorial, which is equal to 6, 5, 4, times 3 factorial over 3 factorial is going to be, and 6 times 5, it is 30 times 4, 120 is going to be. Part B, in how many numbers contain the digit 5? So again, we are not going to select the 5 because 5 is already selected. So from this set, we are going to select only 2 digits. We are going to do this time like that. So from permutation, it's going to be like that. From 6, we are going to select 2 of them. That makes 6 pardon, I forget something here. Now we are going to select 2 of them, but we can, in 3-digit number, we can put 5 into 3 different places. We can put the 5 here, we can put the 5 here, so we can put the 5 here. So if there are 3 different places, so there are 3 different possible cases for the 5. So it's going to be equal to 6 factorial over 6 minus 2 factorial times 3, it's going to be, which is 6 times 5 times 4 factorial over 4 factorial times 3, which is 6 times 5. 6 times 5 is equal to 30 times 3 is going to be equal to 90 different numbers contains the digit 5. If we in the last part, how many numbers do contain 1 or 7 or both 1 and 7? Now here this question we are going to use another method. That's why this question is important. I said here we have 1 or 7 or both of 1 and 7, which means exactly includes one of them, 1 or 7. So we are going to find this question from all possible cases. If we subtract do not contain 1 and 7, we can find contain 1 or 7 or both. We can find this one. What is all? Permutation 7 with 3 without any restriction. Which numbers do not contain? Here, like this one, 1 and 7. So it means that there are 5 numbers instead of 1 and 7. We cancel. There are totally 5 numbers. We are selecting from 5, 3 of them, and this gives us 7 factorial over 7 minus 3 factorial times 5 factorial over 5 minus 3 factorial is going to be 7 times 6 times 5 times 4 factorial over 4 factorial minus 5 times 4 times 3 factorial over 3 factorial 3 times 2 factorial over 2 factorial is going to be, when we simplify this 2, 7 times 6, 42 times 5, it's going to be 210 minus 100, and I think 5 times 4 is equal to 5 times 4, 20 times 3, 60 it's going to be. So 150 numbers contains 1 or 7 or both of them is going to be.